Okay, so today we're going to talk about the distributive property. This is the last property that we're going to learn about. So first we're going to draw a rectangle. Okay, so we have one rectangle here where it's 2 units long and it's 5 units tall. And then over here it's 4 units long and still 5 units tall. How do I find the area of a rectangle? How do I find the area of any rectangle? Not this rectangle, but any rectangle. Jose? Okay, so in your journals write down length times width equals area of a rectangle. Length times width equals area of a rectangle. So how would I find the area of this rectangle right here? How would I find the area of just that rectangle? Elizabeth? Sure. How would I find the area of this rectangle? Nancy?
5 times 2.
Good, because I'm taking my length times my width, and I'm getting 5 times 2. So the area of this smaller rectangle is 10, and we say units squared. And does it matter if I put my 5 first or if I put my 2 first?
No.
We need to think about the commutative property of multiplication. When I do the commutative property of multiplication, if I do 2 times 5, is it the same thing as if I do 5 times 2?
Yes.
So it doesn't matter which order it is. I don't want to focus on length and width. What I want to focus on is, do we know what to multiply and what it's going to tell us? Okay? So you're telling me that the smaller rectangle has an area of 10 units. Okay, so then what is the area of this rectangle? So we know to find area, I have to do length times width. I want to figure out what is the area of this green rectangle. Kevin G? Why wasn't your hand up then? So what would the area be, Kevin S? 20 units squared. And if I have a 2 and I'm calling it squared, we know that 2 is what? An exponent. It is. Remember I talked about 2D versus 3D shapes? And I said when we're finding the area, we use squared. We're finding the area of a rectangle, so it's 2D, so it's squared. Okay, so units squared. Or if they told me it was centimeters, it would be centimeters squared. We always, after whatever our label is, put squared for those. Okay, so I have a question for you. How would I find the area of this entire rectangle? So I found the area of the smaller one, and I found the area of the bigger one. How would I find this entire area? This entire area, the small, the big, the whole thing. Adon?
Add the 2 areas together.
Agree or disagree? Do you think I should add those areas together? So if I know the area of this small one, and I know the area of this big one, to find this entire shape's area, would I add those 2 together to figure out what the whole thing is?
Yes.
So let's try it. Thank you. So what's the area of the entire rectangle if I add them together? Jose?
30 units
Good. So I took the area of the smaller one plus the area of the bigger one to make the entire thing. Okay? Is there a way that I could do this without finding the area of each one? Nancy, you have a question? Yeah.
I think you just wait and multiply times like the answer from the first one, 5 times 2, equals 10, and then 4 times 5 equals 20, and then multiply 20 times 10.
Would 20 times 10 tell me the area of the whole thing? If I have an amount here and an amount here, and I want to find the total between the two, the total, would I be multiplying or would I be adding if I'm looking for the total?
Adding.
Adding, because I want to take what I have here and what I have here and find the total together. So here I'm doing the same thing. What I have here and what I have here, if I add them together, I'm getting the entire shape. Remember, multiplying is when I'm doing, I'm taking something and I'm multiplying it. It's growing. Is anything multiplying here? It's growing? No, I still have one square here and one square here. Rectangle, excuse me. If I have one rectangle here and one rectangle here and I put them together, it's going to tell me what all that is, right? What's another option that I have? Do I have to find the area both times? Could you tell me what the length of this entire rectangle is? Jose?
6
How did you get 6 as your length for the whole thing?
because you cut one below it.
Can you say it louder?
Because if you didn't explain the note, then you said before.
Agree or disagree? Or confused? Can you say that one more time?
I said if you didn't split like the rectangle, you don't split it, and you put 6 on the top.
Does someone think they could say that in a different way? Dylan, do you think you know what he's saying?
So if you didn't split it, then there's 2 quarter pieces.
If I hadn't split this into 2 separate pieces, if I had kept it as the whole line, how would I figure out the length of that line? Adon?
By adding 4 plus 2
I have to put them together. If I put these together, it tells me the entire length.
and 2 and 5 times 3 equals 30.
So I had 30 the first time, right?
Yeah.
If I do the 5 here times these put together equaled what?
6.
Okay. 5 times 6, because my length times my width, equals 30. Same thing. Dylan, say it again. That's a good question. Do I need all of these numbers to find my, it's the same. How do I know that it has to be the same? And to have a rectangle, these have to be equal. And these have to be equal. That's why we only take one of each. So think of an array. I can't have an array where it has 5 over here and only 2 over here, right? That's not going to be an array. When I fill it in, it's not going to match. I'm not going to have even rows. See? So I have to have 5 on all sides. Rectangles are like showing arrays because you're still finding area, right? Arrays are finding the area, the total number of circles. This rectangle, you're following the same rule. You're counting down and you're counting across. But here, instead of counting, they gave it to us or we had to figure it out. So let's both. So let's do another one. So I have two different rectangles here. I have this one and this one. How do I find the area of this pink rectangle? How do I find the area of the pink rectangle? Gael? Seven times 11. Good, thank you for agreeing, Nancy. Jose. Okay, how do I find the area of the green rectangle? Joseph? They can't hear you in the back. Oh, Dylan, do you want to say that in a different way? Squares. Is it square? These aren't squares. Oh, okay. What? Okay, so you're saying like since it's not doing something like this, is that what you mean by it's even? Okay, so since it's all one continuous piece, it means that the length over here is the same as what's over here. Can someone say that in a different way? Because that's an important point to understand. That on a rectangle, what he said about being able to carry that 11 over. Mustafa, can you say that in another way? Jose?
If you see it, like, the question is asking to find the area, it just shows, like, a number, it's like split up. It shows the width, it shows the width that's on one side, and the other shows even.
And how do you know that the other side is even?
If it's not
What shape is this? A rectangle. Adon, do you want to add on to that, knowing that this is a rectangle?
Yes, it's a rectangle, and we give us one of the sides, and we know that rectangle has to be even on every single side, with the other side to be even.
Right, if I had a shape like this, would that be a rectangle? No, because these sides are not even lengths. Okay, so one of the rules of a rectangle is that it has to have even lengths on opposite sides. So this side and this side have to be even, and then this side and this side have to be even for it to be a rectangle. Okay, so if it's 11 here, I know the other side is also 11. Is this a square?
No.
Nancy, why is it not a square? It looks almost even on every side.
Because on a rectangle, there's on the side, there's like two little short lines. And on the square, they're even.
You said on a square they're even. What do you mean?
But they're all the same numbers.
How do you know that this isn't? We have numbers. Mustafa?
All the sides, I think it's just trying to say all the sides have the same number.
So for a square to be a square, all of the sides have to be even. Okay, let me... Nancy, I don't want this to throw you off. Okay, if I cover all that up, the shape that you see has 4 sides, right? You see it? It's still a 4-sided shape, right? It looks almost like a square. This right here. Here, 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 right? 4 sides. Okay. How can I figure out the length of this side or this side? I have a piece that's 3 and I have a piece that's 7. How can I figure out the entire thing? If I have a piece that's 3 and I have a piece that's 7, so all this is 3 and this is 7, how would I figure out that whole thing? Just that side. Just that side. Stacy? If I have a piece that's 7 and a piece that's 3, to figure out this whole entire thing, I add them together. I'm not multiplying and creating new things. Multiplying means I'm creating new things. Am I creating anything here? No. I'm taking a little bit and I'm taking a little bit more and I have to put them together. If I'm putting 2 things together, what is that doing? What operation is that? Adding. I'm adding them. So if I add them together, it tells me what is this entire side length. So is this a square? Does it have all even length sides? Elizabeth? Are those the same number, my friends? No. So is this a square if one side is 10 and one side is 11? No. So if it doesn't have equal sides, what is it called? It's close, but it's not, because this side is 10, this side is 11. So getting back to finding this area, 7 times 11 would give me the pink. How would I figure out the green? I want to hear from somebody new. How would I figure out the area of this green section? Right here. Mela? 3 times 11. How would I take those areas and figure out the whole thing? Stacy? I would add them together. Watch how I write this. Watch. If I take 7 times 11, and I take 3 times 11, and I take those answers, and I add them. Do it again. If I take 7 times 11, which was how you told me to solve the area here, and I take 3 times 11, the area here, and I add them together, that's going to tell me the total area. What's the other way that I could do this? What was the other way that we did? How did we get this 6 up here? Who gave me that 6? Jose, how did you get that 6 on the problem before? How did you get this 6? Where did the 6 come from? So you added those 2 sides that had been broken apart. And you multiplied it times 5 because that was the other side. So what over here is being broken apart? The top is being broken apart? The side is being broken apart into 3 and 7. So if I take 3 plus 7, which gives me that whole side, what do I have to multiply that 10 by? The other side, 11. Would this also tell me total area?
Yeah.
If I take 7 plus 3, which is 10, and I multiply it times 11, I'm doing side times side, would give me
110. Yeah, I had 10.
And up here, if I do 7 times 11 to get the pink, so this one is 77, and I do green 3 times 11, which gives me, and I add them together, 33 plus 77, my total area would be units squared. U for short, units squared. And down here we also got what number? Because I had 11 times 10. So this is the distributive property. Saying that I can do 7 times 11 plus 3 times 11, and that's the same as if I do 11 times 3 plus 7. Where did that 3 come from? Here and here. That was my piece of the line here. My 7, my piece of the line here. They're saying if I add these together and then I multiply, it's the same as if I multiply them separately and then add them together. And we found that it gave us the same answer twice. It works every single time. So if I gave you something like can you write the distributive property? So let's do this one together. I have 6 both times, right? So both of these sides are going to be 6. And then what are the 2 things that I have to put together to figure out my other side? What are the 2 things that I have to put together to figure out my other side? Elizabeth? What 2 numbers do I need to put together in order to figure out a whole side? 1 and 3. So 6 times 1 plus 3, if you see a number right next to a set of parentheses, that is the same as multiply. Okay, so you actually don't have to have a multiplication symbol there. If a number is right next to a set of parentheses, it means to multiply. So I could write this as 6 plus 3. This means 6 times 1 plus 3. Okay? Okay. So if I have 6 times 1 plus 3, what's that the same as doing? If I add these sides together and multiply it times this, it's the same as if I find the area of this piece, and then I find the area of this piece, and what do I do with them? I just add them together. So it's equal to, if I do, how would I find the area of the green?
6 times 1.
And how would I find the area of the pink?
6 times 3.
Dylan.
So that's when we want to pass when we solve it. Do that and solve the area.
This would be the faster. Well, I want you to understand what the distributive property is, right? That's the point of this lesson. What is the distributive property? So the distributive property is just saying that I can find the area of this piece and this piece and add them together. Or I can go ahead and just use these numbers to figure out what that side length is and multiply the 2 side lengths. That's what the distributive property is saying. Okay? So it's also saying anytime that you see, let's do, four times 3 plus 2, what is that equal to? I don't want an answer. Distributive property is saying, what is that the same as? Up here, it's the same as 6 times 1 plus 6 times 3. So what you're doing is you're taking this guy and you're doing 6 times 3, not 6, sorry, 4 times 3, so practice drawing those arrows, 4 times 3 plus, because that's what's there, 4 times 2. So you're giving that 4 to both of those numbers. Just like up here. I had 6 for both of those numbers. 6 times 1, 6 times 3 is the same as if I do 6 times 4. Here, 4 times 3 plus 4 times 2, same thing. So if someone gave you, you're going to do this one on your own. If someone gave you 3 times 2 plus 4, I want you to write what that would be equal to using the distributive property. Using the distributive property, what would that be equal to? Why did you ask? So why did you do this? Should be your reason. This is not a reason for doing this. This is a reason for not having a worksheet. I want to know your 3 reasons that you chose to do that. And that's what should go here. So if someone is distributing papers, what does that mean? I'm handing them out, right? And am I handing them all to one person? No, I'm handing it to each person, right? This is called the distributive property because that 3 is getting handed out to everything that's inside the parentheses. So the 3 gets given to the 2, and it gets given to the 4. So that's the way that we can remember it. It's being distributed, it's being handed out to each of the numbers that are in there. So the distributive property is exactly like triangle variable. So because it's the same on both sides, that's why I can multiply the same amount. The only time we can treat it square. right, so in front of you, you have a distributive property. We haven't done distributive yet.
This is the last one.
This is the last one. Write this. What do you mean in half? No. You're telling me what you did, not the reason. You're telling me what you did. You're not telling me the reason. I want to know why you did that. Oh, yeah, it would have been confusing if I used an x as my multiplication sign instead of the dot. Because I would have had xxa, xxb, instead of x dot a, showing times.
Not spreading the love around the media.
That's fine. Thank you. Is it or no? Iced tea. So it's always, guys. Nancy asked me a really good question that actually is a common mistake that I usually see. So I'm really glad that she brought this up. She said, do I always have to put a multiplication sign between the two numbers and an addition sign in the middle? So the answer to that is, if you see parentheses, parentheses are a new way to show multiplication. Okay? So we have now 3 ways to show multiplication. What? We can use an X, we can use the dot, and parentheses also mean to multiply. But they only mean to multiply if they are connected to something else. Okay? So if I see something like this, that's the same as saying 4 times 2. sure.
Oh.
So if you want to show it like this, that's fine. We're going to be using these parentheses a lot when we start working with variables next week. But if you see something like you would in order of operations, like that, are you multiplying? No, it specifically tells you to add. So the only time that you're multiplying is if you don't see a symbol between the number and the parentheses. Okay? If you see a symbol between the number and the parentheses, you have to do what that symbol says. Okay? If you see a multiplication sign between the number and the parentheses, would the distributive property work?
Yes.
What does it mean when it's right next to the parentheses? It means to multiply. So yeah, if they have 4 times parentheses, that's the same as just having the 4 there. Okay? So parentheses means what operation? Multiplication, unless they tell you otherwise. We are adding in between because what is the symbol in between the 5 and the 9? An addition sign. If it was a subtraction sign, I would be subtracting right here. Okay? You follow whatever this symbol is and you put it here. Distributive property is going to be addition. 99.9% of the time you're going to see it as addition. 0.1% of the time you might see something else. But most of the things I'm going to give you are going to be addition. But what's important is that you understand that this means 4 times 5 plus 4 times 9. This means 4 times m plus 4 times 2. Pay attention. 4 times 2. This means x times plus x times b. Do you see how we're getting that?
Yes.
No? Okay, I want you to fold this in half and glue it on your page. If you need to go to a new page, go to a new page. Fold it in half, get that glued. You have 1 minute to get it done. You can't just say because of what happened in specials, you need to say what it is.
For this one?
Yeah.
For this one, does it matter like if we do addition or subtraction? Because for right here,
So it has to be addition in between because that's what my symbol is here. I'm matching them up. So I'm going in order. X times A plus X times B.
so does it matter like if, for example, we do X times A and then this one we do X plus B? Or
It would matter, it would be different because let's make it like numbers. It's okay, no, I want you to ask me questions. So if we know the variables mean numbers, right? Okay, so I'm just going to make up a number to show you why that won't work. If I have X times A plus B equals X times A plus X. Let's say that X means 2, A means 1, and B means 3, okay? That's not necessarily correct, but it is. Okay. So it would be 2 times A is 1 plus 3. You see how I got that? X is 2, A is 1, B is 3. Okay. Equals, if let's see what I get when I multiply, and then let's see what I get when I add.
Stop shaking the water bottle, cover us.
2 times 3. 2 plus 6 gives me 8. This is the correct way. And then if I do 2 times 1 plus, you want me to do plus here? 2 plus 3. Up here when I multiplied I got 1. And here when I add I only get 5. So if I do 2 plus 5, is that the same answer? No, because you're not. And the bigger these numbers get, the bigger that difference is going to be. Okay, so you have to be multiplying in here. This parentheses means to multiply. That's why we multiply. Okay, because this is saying 2 times whatever's in here. 2 times 1, 2 times 3. Inside the parentheses, it's always going to be multiplied. Unless they